Okay, everyone. I want to go over two more stoichiometry problems just so everyone kind of has more practice that they can work with. So here's a new chemical equation. This substance here is magnesium nitride, and this is potassium oxide without the minus in there. Magnesium oxide, and this over here is potassium nitride. I know a lot of people have had questions like, hey, how do I tell what formula is which? And over time you get better at that, and we will have more practice throughout the year. But let's say I was given a problem like this, and let's say I was given 10 grams of magnesium nitride, and let's say for the heck of it, I want to find out how much mass of magnesium oxide I could produce from this. So that's my problem. All right. Again, the question mark is, I'm going to put grams here because I want to know how much mass of this I could produce. All right, so you should be following kind of a step-by-step procedure. Obviously, this is going to be written out as a word problem. Here, I'm just kind of telling you what's going on. You need to find out what the problem's asking you. All right. The next part of the procedure, if it hasn't been done already, is you need to make sure the chemical equation is balanced. Okay, so just kind of do a double check here. I've got 3 magnesiums here because of the subscripts. Do I have 3 magnesiums here? Nope. Going to have to balance this. So if we try to do this by trial and error, I'm going to try to balance the magnesiums first. I'm going to put a 3 here. And what does that do? Well, I also notice a problem immediately. I've got 3 potassiums here and 2 potassiums here. So that's an even-odd type situation. So I might have to go back and erase my initial 3, and I might have to start balancing by balancing potassiums. All right? So if you see a 3 and a 2, well, that's an even-odd type situation. You want to go to lowest common multiple, which means I'm going to make the lowest common multiple a 6 and then multiply each of those accordingly, so I end up with 6 potassiums. Okay, if I do this, 6 potassiums over here, this will give me 3 times 2 is 6 potassiums, and 3 times 0 are 3 oxygens, which means I probably could have left my 3 in front of the magnesiums. 3 oxygens here, 3 oxygens here, 3 magnesiums, 3 magnesiums, 2 nitrogens, 2 nitrogens. Okay, so we're on the way to being able to, the equation's balanced now, so we can start talking about our stoichiometry. After you figured out what the problem's giving you and what they want, your next step is to ask yourself, do you need to convert to moles? Right? And if you come over here and you see a mass, then that answer is yes, right? To convert a mass to moles, so before we do anything, before we start looking at the chemical ratio between what we're given and what we want, we have to convert this number to moles, right? So if we remember, converting to moles, I have to take this mass divided by the molar mass of this. All right, so let me stop for a minute and write some stuff in. Okay, so this is the equation we all remember. Moles equals mass over molar mass. The mass that I'm given goes here, and all I need to do now is determine the molar mass of magnesium nitride. Magnesium nitride has 3 magnesiums. Each magnesium has a mass of 24.3, and I'm getting this from the periodic table, and that's times 3. All right, I'm going to get an answer for that. And then I've got nitrogen, and nitrogen has a mass of 14, and there's 2 of those. So I'm going to multiply top and bottom, and then add what I get together, and we should get, when we're all said and done, okay, I get 76.6, and that is the number of grams in 1 mole of magnesium nitride. Now I know a lot of people are still, they're not really down on the whole mole concept, but I guess what we're saying is 76 grams of this stuff will get you 6.02 times 10 to the 23 of these things altogether. Okay, so now we still haven't found the number of moles in 10 grams, so let's do that next. So I've got to take this, and I'm going to go 10 grams divided by 76.6. So what we're saying is it takes 76.6 grams to get to 1 mole of magnesium nitride, but I only have 10 grams. That means I have a fraction of a mole. I'm going to end up with a decimal number here. So if I do this, take 10, I end up with 0.13, and this is moles of magnesium nitride. Mg, it's really hard writing with a mouse, Mg3 and 2. So now, this is just precursor information that you have to know how to do. Now I'm ready to look at the molar ratio between what I'm given and what I want to find. All right, so I'm going to write down two ratios, or sorry, I'm going to write down a ratio. So I know the ratio is, I'm going to write it as magnesium nitride to MgO, and that ratio specifically, there's no coefficient in front, so this has to be a 1 divided by a 3. So there's, no matter what, no matter how much magnesium nitride and magnesium oxide I make, there's always going to be a 1 to 3 ratio between them. So what are they giving us in this problem? In this problem, they're not giving us 1 mole of magnesium nitride. They're giving us 0.13 moles. So a 1 to 3 ratio is going to be the same as 0.13 to x. So whatever 0.13 over x has to be, it's got to be end up the same as 1 divided by 3. So I can do some cross multiplication. 1 times x equals 3 times 0.13, and that's going to give me x, the number of moles of MgO, as 3 times 0.13. Okay, so we end up with 0.39 moles of MgO. That's this stuff. So 10 grams of this can give us 3.39 moles of MgO. Now that's not what the answer wants. The answer wants us to go to mass. So we have to take this answer and go one more step and turn it back to grams. Okay, so test yourself right now. How do I convert moles into mass? I can multiply, right? I need to take moles that I'm given times molar mass. So I've got to go and find the molar mass of this material. So let's do that quick. We know Mg has a mass of 24.3, and I'm rounding, and that's okay. Oxygen has a mass of 16, so we've got to add these. 6 and 4 is 10, added to 2 and 3 is 40. If you got 40.3 grams per mole, you've done well. So let us kind of extend the page a little bit here. I'm going to need to multiply 0.39 times 40.3. And you go ahead and do that with your calculators. That's going to give us the number of grams of MgO we're going to end up with. Okay, and we're back. So we ended up with 15.72 grams of magnesium oxide. And that's the deal. So basically 10 grams of this, when we're all said and done, can make, what was the number? 15.72 grams of this. So let me write that up there. 15.72 grams is the same amount of magnesium oxide, the same number of moles. Let me start that over. 15.72 grams of MgO represents exactly 3 moles of MgO. And we know that's a 3 to 1 ratio. So that's how we can get 10 to 15.72. You notice it's not the same. It's not double. It's not triple. A lot of people still want to say, hey, 1 to 3. A lot of people right here where you're supposed to use moles, a lot of people just want to put in mass. And we know that's not correct. All right, we can't just plug in the mass that we're given, 10 grams. We have to convert it to moles first. All right, so I think I'm going to cut this short. Instead of making this 2 more stoichiometry problems, we're just going to go, we're going to call this 1 more, and we're going to have a good day. All right, so to do this, what I recommend you do, you've listened all the way through to the problem once. Now go back and start with a blank page, write the equation over at the very beginning, and reattempt the problem. Except attempt it this way. Let's say the second time you do this, let's say you were given 10 grams of magnesium nitride. Now, let's say you want to find out how much potassium nitride you can form from this, all right? So make that as a test, and what I'm going to do in just a moment, I'm going to put the answer to that problem on another page, all right? So give it a shot, pause the video right now, and do that part of the stoichiometry problem, and then restart the video, and we'll show you the answer, okay? Okay, if we're wrapping this up, we found out that 10 grams of magnesium nitride gives us 0.26 moles of potassium nitride at the very end. And then we converted moles back into mass by multiplying by the molar mass of potassium nitride, which ends up giving us 34.1 grams. So give yourself a pat on the back if you got that answer. All right, see ya.